All right, hello, this is Brian again, and I'm going to solve problem 10.3. So we need to show that J2 is also equal to 1 over 6 times, I'm not going to say it, it's just this mess right here. So when I first did this problem, I tried to use the last part of equation 10.9, this right here. And truthfully, it just created a mess, and I gave up partially the way through. So what you're actually supposed to do, that I figured out after watching everybody else's videos, is that you're supposed to use the middle part of equation 10.9, this part right here, not the last part. So using that middle part, we can then start to accumulate terms. Okay. So first, we expand out this trace to this equation here. Once we do that, we can then substitute in um, sigma prime equals sigma minus 1/3 trace of sigma times I. And it will give us this equation here, which starts to get long and messy, but we're just gonna trust the process. So to keep this a little simpler and to save myself from making 400 sheets of paper for one question, I let C equal to this expression right here, 1/3 theta 1 plus theta 2 plus theta 3. That's because that is unchanging and a constant. And we'll substitute it back in later once we sort all this stuff out. So doing that, we get this next equation here. Expanding that, we get these two respectively. Then expanding this out again, we get that. And once we gather our terms together, I noticed that we had 2/3 of this plus 1/3 of this. This used to be expression C, but I've substituted back in at some point in one of the previous steps. Sorry if I'm going a little fast. But anyway, and eventually we can get rid of this side altogether. And we have what's remaining is 1/3 sigma 1 plus sigma 2 plus sigma 3 squared. So we're going to expand that. And that is a lot, that creates a lot of terms. And so once you group them all together, it looks something like this right here. And so I took this and I took a colored pen to help myself keep track of it all, and I rearranged it. So rearranging this, we have two sigma 1 squared up here. You can see we have sigma 1 up here down here twice. Then this here, two sigma 2 squared, that appears again here and here. Two sigma 3 squared appears here and there. So I'm just breaking these sigmas apart. Then we have these double terms, as I'm gonna call them. So we have two sigma 1 sigma 2. We're going to need that. We're going to put it over here. We're going to take this one, put it there, take this one, put it there. And you might recognize these as the expanded forms of our final equation, which is sigma 1 minus sigma 2 squared. That is this junk right here turns into this junk right here turns into that, and finally this turns into this. And we have accomplished going all the way through to the end of our proof, where J 2 is equal to 1/6 of sigma 1 minus sigma 2 squared plus sigma 2 minus sigma 3 squared plus sigma 3 minus sigma 1 squared. Alrighty, and that's 10.3. Thank you.